We are continuing in Chapter 7. Today we're going to look at bisectors of triangles. Bisectors of triangles. So what is this? Well, we're going to talk about perpendicular bisectors, and we're going to talk about angle bisectors, and we're going to put them inside of a triangle and talk about some things that occur inside that triangle. All right, so here we go. A perpendicular bisector is a figure that bisects a segment and is perpendicular to the same segment. Now, as you notice in that, you will notice it does not say that it connects to a vertex or anything like that. So as we look at this first one here, we look at this first picture, our perpendicular bisector would basically be about right here. Now, that means it's going to be perpendicular here, and it's going to bisect that side. We would also have a perpendicular bisector that would be like this right here. Now, that is going to be perpendicular to that side and bisect that side. You would also have a perpendicular bisector that would be something like this. It would be perpendicular to that side, and it would bisect that side. Okay, so that's what a perpendicular bisector looks like. Each side of the triangle has a perpendicular bisector. The next part we have is an angle bisector. Remember, an angle bisector is a figure that bisects an angle. So what we simply have here is, like if I drew this first one in, it would look something like this. And it's going to bisect that angle. If I drew another one, it would look something like this, bisecting that angle. And then if we drew the third one in, it would look something like that, and it would bisect this angle. Okay, so we have a bunch of those. All right, so now let's talk about why are those things important. So what we're going to be talking about over the next couple days is, it's called point of concurrency. Okay, point of concurrency. We're going to talk about some special points that show up inside of a triangle. The first one is what we call the circumcenter. The circumcenter is the point of concurrency. In other words, the point where the three perpendicular bisectors meet. Okay, so if we draw those out, I'm going to draw all of those using red here. So we have this one. We have this one. And we have this one. Now, when we look at it, this point right here then would be called the circumcenter. Okay? Now, what I'm going to do is I'm going to try to erase here a little bit, if I can, and just draw it straight to that circumcenter, just so you kind of see the smaller portion of that. All right, so there are the three perpendicular bisectors inside of that triangle. Now, like I said, that black point there is called the point of concurrency. It is called the circumcenter. Okay? Now, the second part to this is, so what? Why do we need to know the circumcenter? Well, here's the part that's kind of interesting to us. The circumcenter is equidistant from the three vertices of the triangle. So what that means is if I were to come back in here and I connect the circumcenter to the vertice. And I connect the circumcenter to the vertice and the circumcenter to the vertice. Then what I know is that all three of those pieces are equidistant. That's what I know by that, okay? So how do we use that? Well, here's what we do with it. So if I look at this problem, I know that EG, DG, and FG are perpendicular bisectors. So I'm going to mark up that part. I also know then that this point G is the circumcenter. So remember what that tells me then is that tells me that BG, AG, and CG would all be equal to each other. Okay, so I'm just going to write that down here. I know that AG is equal to BG is equal to CG. Okay, now in this type of a problem, the next thing we need to do is kind of fill in what we know and what we don't know then. Okay, so I'm going to start in and I'm just going to start putting numbers in. So it says GE is 7. It tells me GC is 6x minus 15. It tells me FC is 3x plus 3. And it tells me GF is 9x minus 5. And it tells me BG is x plus 5. And I have to find GC. So I need to be able to find the value of x. So I start kind of looking here and I say, okay, what would be useful to me? And really, what doesn't even have a use at all? Well, I don't know any relationship between those two perpendicular bisector pieces. I don't know that. I also only know that FC, this part, and this part would be congruent to each other. So those aren't going to help me. But if I look here, so this one's not going to help. That one will. This one's not going to help. This one's not going to help. But if I look here, I have BG and I have GC. And we've already said that those are going to be equal to each other because G is the circumcenter, and those are the segments that go from the circumcenter to the vertex, which means those are equal to each other. So therefore, I'm going to take 6x minus 15, set it equal to x plus 5. Now I'm going to minus my x, so I get 5x minus 15 equals 5, which is going to give me 5x equals 20. So that's going to tell me that x is equal to 4. Now my last piece, though, is I want to find GC. So I go over here, I find GC. GC is actually equal to 6 times x minus 15. So 6 times 4 is 24 minus the 15. So that tells me that GC is equal to 9. So that's how we use the circumcenter to find some measurements inside of a triangle. All right, the next point of concurrency that we are going to look at is called the incenter. Now, so let's talk about what the incenter is. The incenter is the point of concurrency where the three angle bisectors meet. Okay, so where do the three angle bisectors meet? So what we'd be looking at here is something like this. We'd have something like this. and we would have something like this. So this point right here would be the incenter. Okay? Now, okay, cool. What does that mean? Well, the incenter now is equidistant from the three sides of the triangle. So what does that mean to us? That means that it is going to be perpendicular to the other side. It is going to be perpendicular to the other side. And it's going to be perpendicular to the other side here. And those three measurements would all be the same. Okay? Now, notice that is not a perpendicular bisector because it's not bisecting the other side of the shape. It's just coming in at a perpendicular. So here's what we know right now is we know those two angles would be the same. We know those two angles. We know those two angles because those bisect all of those. So all the purple lines are bisecting all of those angles. And then the green line is the equidistant to the three sides. And remember, the shortest line that is equidistant is the perpendicular to that other side. And that, remember, is called our incenter. Okay, so let's take a look at this next picture then. So what I'm told is I want to find NF, okay? So as I look at this, the first thing I notice is that N is the incenter, okay? I know that. And I know then that we have some measurements that are equal to each other. I know that DN, I know that EN, and I know that NF would all be equal to each other. Okay? So now let's go through and figure out how do we find the value of X and also then find the value of NF. Well, if we look at what we're given ND, so this segment here, we're told that is 5x minus 1. We're given NE, this segment here, and we're told that is 2x plus 11. And I'm told that NG is 21. Well, clearly, if you kind of look at it there, you can recognize that we don't need the 21. The 21 has nothing to do with that distance from the incenter perpendicular to the other side. But I do notice that if I take ND and set it equal to NE, that I should be able to find X. So 5x minus 1 equals 2x plus 11. I minus my 2x, and I add the 1. So therefore, x is equal to 4. Then we want to find NF, so I'm just simply going to plug that back in. It doesn't matter if I plug into ND or NE. I do know they're the same value. So all I'm going to do is I'm going to say, okay, NF is equal to 2 times 4 plus 11. 2 times 4 is 8 plus 11. So NF must be equal to that. So therefore, it must be 19. And remember, this is all off the fact that N is the incenter, making ND equal to NE, which is also equal to NF. And that's the value we were looking for. So that's how we use a couple of our point of concurrencies. We were looking at our circumcenter and our incenter on those.